The purpose of this lesson is to demonstrate how we can use completing the square in a more difficult quadratic equation. So the example we're going to have is factorize negative 4z squared plus 4z minus 17. Okay, in previous lessons we've learnt that in order to complete the square, the coefficient of the z squared term must be 1. The only way of doing that is to take out, in this case, a negative 4 as a common factor. And so we're left with z squared, now minus z, taking out negative 4 as a common factor. Now we can close the bracket because the 17 never really comes into the completing the square part. We deal with that a bit later on. So now we've got negative 4 brackets. Now this is the bit that I'm going to be completing the square on. So that's fine, z squared minus z. Now remember, we halve the coefficient. The coefficient is negative 1. We halve it, we get negative a half. We square it and we get positive a quarter. So say that again. We halved it, we got negative 1 over 2, negative a half. We square it, we get positive 1 over 4. I can't just go adding a quarter. I need better get rid of that quarter that I just added. Close the bracket. Take away 17. It's really important that you close the bracket in the right place. Okay, it was only the negative 17 that was left outside the bracket, so make sure you do that now. However, it's this bit that I'm really interested in. Those first three terms become my perfect square. So what I'm going to do is leave that inside my bracket. Now I'm going to close my bracket. But in order to close my bracket there, this fella here needs to get out. In order to get out of the bracket, he needs to be multiplied by negative 4. So negative 4 times by negative a quarter is going to be a positive 1. 4 times a quarter is 1. Take away 17. Okay. Now, the part in my bracket I know becomes a perfect square. I know that has to be a z because z squared is z squared. The number here becomes whatever I got when I halved the coefficient of z. The coefficient of z was a negative 1. When I halved it, I got negative a half. If you check this, if you expand it, you should go back to that. First term squared, yes. Twice the product of the two terms, that would be z over 2, and then double it would be z, negative z. Second term squared, a half squared gives a quarter, so I know that is correct. Take away 16. Now, tricky step here, because what we want to do is be able to factorize this, and where we're heading towards is trying to get an a squared minus a b squared. The problem is here, we've actually got, it's be easy to miss this, we've actually got a negative here. We've got negative a squared minus b squared. That can't be the case. So what I need to do is convert this thing back into a positive. I can make it a positive by putting an I squared there. I squared is negative 1, so you can see that's really negative 4, which is what I wanted. Take away 16. I've now got a squared minus b squared. So that is going to be equal to a minus b, a plus b. Now a is going to be the square root of all of this. The square root of all of that is going to be a 2i and a z minus a half. In other words, I lose the squares. So a minus b, the square root of 16 will be 4, and a plus b. Now I can simplify this a bit. It would be 2iz, multiply out these little brackets. 2I times minus a half will just be minus I, minus 4, 2iz minus I, plus 4. Finished. So that's the fully factorized version of this polynomial. So what we're really looking for is to get this a squared minus b squared. And sticking that I squared in was able to convert this to a positive, so we had positive a squared take away b squared.